something that I think you guys have probably done before. I'm not even going to worry about those. Again, my trick, you've definitely like foiled before, like two binomials, but I don't know how much we have done. Oh, this isn't plugged in. I don't know how much you have done about much more beyond two polynomials or two binomials. But like I said yesterday, I just take each term. You essentially have to distribute each term, and I just make sure it hits everything. And I'm going to show you guys a little trick that for some reason I actually didn't really learn until college for whatever reason that I think just makes it so much easier. So I'm going to focus on this negative 4x first, and I'm going to hit that to everything in here. So negative 4x times 2x squared, that's going to be negative 8x cubed, and then negative 4x times negative 3x is going to be positive 12x squared, right? X times x is x squared. And then we do it to the last one here. Is going to be minus 16x. And now I can do this minus 3 to each of these. Minus 3 times negative 2x squared is going to be negative 6x squared. And you'll see what I'm doing is I'm lining up these x squareds, right? And that's basically the little trick to make this a lot easier. Negative 3 times negative 3x is going to be positive 9x, and I lined up the x's. And then negative 3 times 4 is minus 12. And now that I did that I lined it up super nice, instead of like having one long thing, right, where I have to then find the like terms and combine them, now they're just all lined up very nicely for me, and I can just write negative 8x cubed. Negative 12x squared minus 6x squared is going to be minus 18x squared. Negative 16x plus 9x is going to be minus 7x, and then that minus 12 by itself. All right, and so I think that lining them up like that just makes it so much easier. And you can do that, no matter how many you have of each one. I think that is simply the easiest way to go about it. I will leave this slide up for an extra couple seconds in case anyone's copying it down or taking a picture or doing whatever. Okay. Move on to this one. And now that it's a trinomial times a trinomial, still the same idea, right? I'm going to do this one, and I'm going to do it one at a time with each one over here. 2x squared times 3x squared is going to be positive 6x to the fourth. And then 2x squared times positive 2x is going to be 4x to the third. And then a negative 3 is going to be minus 6x squared. And now I can do this minus 3x to everything over here. Minus 3x times 3x squared is going to be minus 9x cubed. Then to the 2x is going to be minus 6x squared again. And then to the negative 3 times negative 3 is going to be plus 9. And then this one just has an x. And then we can do this last one. Positive 4 times 3x squared is going to be 12x squared. So I'm going to line that up with the squareds. And then plus 8x. Right? And then minus 12, multiplying them all. And then again, writing out 9 terms left to right and then combining like terms just seems so cumbersome rather than, lining them up like this. And then in the end, adding them, I just think that's so much easier. So make your life easier, right? And then 6x to the fourth. 4 minus 9 is going to be minus 5x cubed, negative 12. These all cancel out, right? Minus 6 plus 12. Those end up canceling out. 9x plus 8x is going to end up being 17x. And then just that minus 12 is by itself. And so this would be our final answer. And it's in standard form, right? Highest degree to lowest. So I'll leave that up there for a second in case anyone needs to finish writing or take a picture or whatever else you need to do. Okay. This one I think has a pretty important idea in it. So the multiplication is all here, right? And it's like kind of grouped by these parentheses. You can think of everything in the parentheses as just like a single number, right? A grouping of stuff makes a single number, right? Once you throw something in for x, you get each of these just a single number. And, maybe just to give the idea here, right? If we had 2 times 3 times 4 times 5, not only can you multiply in any order, but you can do 2 times 3 and then do 4 times 5 and then multiply those, right? 2 times 3 is 6 times 4 times 5 is 20. That gets us 6 times 20 is 120, right? That's one way to do it. Or you can, multiply 3 of them together, right? 2 times 3 is 6 times 4 is 24. And then you solve that times 5, right? 24 times 5 should also get 120, right? That's, another way. Really, the idea is when you multiply these, you still have to multiply them by the others, right? So when we're working with polynomials, it's the same idea, right? We can multiply this and this, but then whatever we get out of that, we still have to multiply to this. And if we did that, we'd still have to take that whole thing and multiply it by this, right? And so I think maybe the easiest way for us to do it is to break this one up into these two multiplied together and then multiply those. So binomials, maybe we're comfortable with them. I'm going to go a little fast on them just because it's more about the idea here. 4x times 4x is going to get us, and I'm going to put this in parentheses, 16x squared. And then we're going to get 4x times negative 3, which is negative 12x. But then we're also going to get 4x times 5, which is plus 20x. Right, so together that's plus 8x. And then 5 times negative 3 is minus 15. So that's that trinomial. Now multiplied, and then I'm going to do these two multiplied together. X times 2x squared, or 2x is going to be 2x squared. And then we're going to get 2x, right? 1 times 2x, 2x, and another 2x, x times 2. So a total of 4x. And then 2 times 1 is 2. So I've just multiplied both of these, but they're still being multiplied together. So now I need to do that whole thing again where I take this and I hit each of these, and then I do that for each term. So 16x squared times 2x squared is going to be 32x to the fourth. 16 times 4x is 10 times 4 is 40. 6 times 4 is 24. So 64x cubed, and then 16x squared times 2 is again 32, and then this time it's just the x squared. Now if I do the 8x, 8x times 2x squared is going to be 16x cubed. Someone's unmuted. You might want to mute yourself. Sir. Wait, who is it? That's your. Okay. Okay. 16x cubed. Okay. Where was I? Okay, so I did that one, and then 8x times 4x, 8, 16, and that'll also be, let's do it in red. 32, and then that'll be x squared, and then 8x times 2 would be 16x, and then one last one to do, this minus 15 times 2x squared is going to get us minus 30x squared, and then times 4x is going to get us minus 60x, and then times 2 is going to get us minus 30. And then because I set it up so nicely for myself, I made it really easy to add these. We have 32x to the fourth all by itself. 64 plus 16, that's 70, 80 x cubed. 32 minus 30 is just going to be 2 plus 32, so plus 34 x squared. And then 16x minus 60 is going to be a negative 44x. And then that minus 30 is all by itself. So a little cumbersome, but again, not too bad if you do it in a way that helps you in the end, which I think is stacking them all up. And I think it's easier to do a trinomial times a trinomial, right? Because you could do the binomial times binomial pretty fast, and then trinomial times trinomial. We did one of those. But if you do like one at a time, I feel like sometimes that just like is really slow, right? If you do this times this, you get a trinomial. Then you times that trinomial by this binomial, and then you take that and you times it by this binomial. That seems a lot longer than doing that. But you could do it that way. And then this last one I'm not going to do. I just want to hound again that because of this plus sign, this 3 cannot just get like distributed there, right, to the third. What that really means is 3x plus 1, the entire thing, 3x plus 1, the entire thing, 3x plus 1, times itself 3 times, right? So in this case, I would do probably these two multiplied together, and then you get that whole trinomial, and then you have to times that by 3x plus 1. So that trinomial would be 9x squared plus 6x plus 1. There's also a thing called Pascal's triangle, if you remember that, if you've ever looked at that. If you haven't, that's fine. You could look it up. I'll write it down in case anyone wants to. Pascal's triangle. And it helps you when you cube things or take something to the fourth or something